I'm Cathy Skowron. I'm a ranger for Cape Cod National Seashore. I'm also working as an education ranger with the Seashore and ARM through the Department of Energy. ARM stands for Atmospheric Radiation Measuring, and for the year from June or July 1st, 2012 through June 30th of 2013, ARM has set up this mobile facility here within the bounds of Cape Cod National Seashore. It's a mutually agreeable arrangement. And what you're looking at is some of the equipment that ARM is going to be using to test this, different parts of the atmosphere. They want to know what's in the atmosphere downwind of the continent of North America as the winds flow from the continent offshore here. We're out here on the end of Cape Cod. We're the last place where some of the atmospheric part, the aerosols and whatever else is in there, and that's what ARM's trying to find out. ARM doesn't actually use any of this data themselves. What they're doing is collecting it and putting it in a digital archive for any scientists or anyone else actually who's interested to log on to their website and access for free information that has to do with clouds, cloud formation, cloud size, cloud height, cloud shape, where in the atmosphere the bottom of the cloud is in relationship to the Earth's surface, as well as the height of the cloud, and also what are clouds made out of? What are all these little particles of aerosols that are in the atmosphere? They want to identify those aerosols, find their source, and also how many of them are, and figure out the dynamics of the clouds and the aerosols mixed together. So some of the equipment that they have here, most of it focuses directly above this site. It's called the two-column aerosol project, and one of the columns is, as I said, the air directly above this site. So most of the instruments here are collecting information from the atmosphere just from this site. That's column one. The second column is from an airplane that will fly twice during this the year of this project. It flew already during the summer, will fly again in February. The plane will be based out of Hyannis, Massachusetts, and has many of the same, or most of the same instruments that are here in the field, and will fly out to sea about 50 miles or so, collecting atmosphere from that particular column. So that's where the two columns come in. So some of the equipment that you see here, some of these instruments, the one that's moving, this large one, is actually one of the few instruments that does the whole sky, that focuses not just on what's directly above, but scans the whole horizon. It's a microwave cloud scanning radar. So it, as you can see, as it moves, it's collecting images of what's in the sky overhead. This large dumpster-shaped instrument is a wind profiler, and it measures, and I don't know how exactly that it works, but it measures horizontal winds. And I'm thinking of it as, I'm thinking of it as in terms of the way a seismograph might work. So that maybe there's reading somehow that shows if there's a lot of wind, or the wind increases or drops off, there may be some kind of graphic that goes with it. The three instruments that look sort of like mailboxes are radiometers, and they're measuring liquid moisture in the atmosphere. They can't measure anything that's frozen. So there are different aspects of liquid moisture in the atmosphere. Some of what look like flagpole towers, they're the ones that are measuring surface aerosols as they're here on the surface. And then let's see. And then you can see beyond the wind profiler, there's just a simple weather station, a surface weather station that you might have in your own backyard. On the top is an anemometer to measure wind speed and direction. There's humidity sensors. There's also a barometer and a rain gauge that has a light beam through it. So when it rains, the rainfall, the raindrops break that light beam and measure the amount of rain and the velocity. And let's see, what else is up there that you can kind of see? Well, you can hear the beeping. That's the SODAR. And the SODAR is sending a sound wave up into the atmosphere to, let's see, the SODAR measures air turbulence, vertical and horizontal winds. Hear it? And that reminds me that most of the measurements taken here are either through sound waves like the SODAR, or light beams. There's a LiDAR that you wouldn't see unless you were here at night, and then there's radio waves, and they're all on different megahertz and kilohertz that in different bands that they're measuring. And the sound and everything is, all the data is collected on computers and then archived. And as I said, scientists or anyone else who's interested anywhere in the world can access it through their website. And then the data is expected to be used to help figure out, to make the most accurate models we can make to help us predict what climate change might look like.